Okay, good. I started recording now, so we're going to do experiment. Experiment is very, very simple. So the simplest part. So you start writing this first and simply enumerating the experiments. So there's some examples. We'll skip this first. So excuse me. So there are some, I promised to give you a word tutorial written out. So I will do that. This is my reminder for me. And then there are also tutorials on the internet and some hints on using the word. So here is how to write a title. This, I think, is a very important exercise I wanted to show today, particularly because you're trying to choose a title for your thing, right out. Figure 1 represents the potential energy. So remember, I gave you a writing assignment a while ago. So they have two hydrogen atoms coming together. Energy is plotted as a function of internuclear distance and so on and so forth. And I asked you, hey, write a title for it. And different people have written different titles, etc. And so it's a very simple example to illustrate how hard it is to write a good title. And so we need to master this. So you take published papers and pull out a figure and then write the caption for it and see how well you can do compared to what is already published. This is the only way for us to learn how to do this and improve on, right? So I keep saying this, follow the master. And then you develop your own style from there, then on. So figure 1 represents the potential energy curve of hydrogen molecule as a function of intermolecular distance between the two hydrogen atoms. This is the original title given in the Gen Chem book. I pulled it off the Gen Chem book and put it up and showed it to you. And that's the original caption. So then you can put a caption saying figure 1, full stop. So there's a difference. Figure 1 represents. So this is sentence contains figure 1. So here, this is more professional style. Figure 1, period. The next, there is a space. Change in potential energy as two hydrogen atoms approach. Very brief and very, very simple. Of course, there should be a period at the end here. And so then that sentence is complete and very definitive and very accurate. And then later on, you can refer to figure 1 in your text because figure 1 is just one bit and then the second bit begins. So you can refer to that specifically as figure 1, 2, 3, 4, 5, 6. And so all the rest of them are written that way because that's the scientific format of writing a caption to the figure. You need to put the figure, space, number, full stop, space, then the word begins. Not like that in a caption. It is not written that way, right? So that is a scientific format. And then this is a very brief, if you don't have much space and you really have to, crunching, then this is, and also it still has all the essential information that you're looking for. Changing the potential energy as a two hydrogen atoms approach. Potential energy of hydrogen molecule as a function of the internuclear distance. So this is slightly more elaborate. It has few more words in it. And so you need to pick what is it that you like out of these different flavors I've created here. Plot of energy versus internuclear distance for the hydrogen molecule, right? So still they're all clear. They're all brief enough. And they're all shorter than the initial original. So most of these are actually better than the initial ones. So this is how I learn. And the energy of the hydrogen molecule changes as a function of the internuclear distance. So you can tell the same material in many different formats, many different ways, the infinite ways of making that representation. You want to make it clear, you want to make it concise, and you want to make it correct, precise to what is required. So those conditions are satisfied. It's hard to pick one over the other. If you were to, take something that has a fewer number of words, usually that's generally very efficient. 2 and 4 seem to be pretty good. 3 and 4, 5 are not too bad at all. So there are multiple choices you can make, and there is no one exact solution here, right? So so there is some degree of flexibility allowed. So now onwards, bring your own article, or you can use mine if you don't have one, and do writing in the class whenever I keep asking you, right? So today we did a little bit of introduction, 5 minutes or something. Then we will do 5 minutes of results in the next class. So you can bring your material and let's practice it. So whatever the topic is that day, we're going to do 5 minutes of practice of that. And I think this is the only way to learn. You can be either your own article or somebody else's paper, you bring it in and then you look at how did they do it. And so then in this particular case, for example, I would like you to do a 2D format of outline or 1D format of outline and compare the two. 2D is in the Excel format, we discussed this, and 1D in the outline Word format. And so today you're not going to do it in the class because we don't really have enough time. Usually we have a full hour and a half or something, then we can do this. So today we already finished our assignment for. And so the experimental section, it appears in the middle of your document. See the title, abstract, intro, and then experimental. And after the experimental results discussion, generally this is how it is. In some journals, experimental is shoved off to the end. Okay, and that's not too satisfying for me because when I read, I want to read how the experiment is done before I see what the results are. And then I can picture how the result was obtained. And without that experimental, I have difficulty imagining how the measurement was made. And so I prefer this, and most journals do too. So your paper will have this kind of a format. Some people ask me, what is the format for? This is how your format is going to be: title, abstract, intro, experimental, then results, discussion, conclusions. So I put a lot of length between these two because that's today's topic. We're going to look at 3 main subcategories within experimental. So almost every experimental will have these 3 components in it. Okay, and these days we are putting a 4th component about safety. And some journals actually require that, a comment on safety and any hazards involved in carrying out the experiment. And so that's if the journal requires, that will be the 4th requirement. So this is my outline for experimental already. This is standard. So you can use this. Chemicals and supplies. So what chemicals did you use and what different kinds of supplies did you use? And there's a format for how you write all that. And so I will show you how that is done. And it varies from journal to journal, which is aggravating, but that's life. Then method, experimental methods used is to add this to that star filter and then heat it and cool it and precipitate and whatnot, crystallize. So those specific methods are given for each and every experiment that you have done. And then analysis, how you analyze all your data. Some of them give you software packages, statistical analysis methods, and any special equations that you have used or developed, derived, adapted. All that goes into the analysis piece. And in other words, you explain how you analyze your data, how you collected your data, and what you needed to collect your data. So this is how it's all data-driven process. And so this is how it is. Even for computational studies, of course, you don't have chemicals, but you do have supplies. What computers do you use, what generation, etc., and what software packages, what versions, and who is the supplier. So all that you mentioned, your method, how the computation was carried out, and then how the data were analyzed. So essentially the same thing fits in almost every kind of research paper you write, at least in science. And so I pay attention to this topic. That's because this is the central experimental section, the most important part. Because if you can't repeat the experiment, there's no science in it. So in order to be able to repeat the experiment, it needs to be documented well. If it is not documented, then nobody can repeat it. Nobody can repeat unless it is well documented. And so this is unfortunately the most important part in a publication, given the least priority, unfortunately. And we scientists don't pay enough attention, and then we neglect it. And as I said many times, this shoved off to the end. Or even worse, in many journals tell you put the experimental in the supplementary information. And so then the whole thing is lost, because if the supplemental, because a lot of people don't pay, the reviewers included, don't pay attention to the supplemental. So whatever is written in the supplemental is just, who knows what happened there, kind of thing. But that's where the reproducibility of the experiment comes into the picture. So the reputation of the authors is at stake. Reputation of science is at stake. And so the experiment is really, really important part in science. and it should be highlighted, not relegated to the edge. So there are some, methods journals and methods in entomology. I'm an editor for that, volume editor for that, and there is methods in biological reactions or biochemical methods and entomology methods, as I said, and molecular biology methods like that. So there, the experimental is the centerpiece. You get a little introduction, describe in detail how the experiment was done and how the analysis was done and how you ensure that everything is working well. And then a little bit of results and discussion to come as completion, but the experiment is the main piece. So those things are becoming less and less popular, unfortunately, because that's where the state of the art lies, and that should be, paid a lot more attention to. But that's how life is. So we always document everything in the supplementary material, and the journal maintains the supplementary material. It's obligated to do so, and so anybody can access for free of cost. And so we put in a lot of stuff in the supplementary, very detailed methods, and so that the reader can reproduce your data. Because otherwise, science has no value to it. And so that's the most important part, unfortunately, put away in some remote corner. Essential to reproduce data, so that's cannot be reproduced, and it's of low value in science. Not every reader will read this piece. This is what is unfortunate thing is, but they should. Reviewers will read this part to some extent to make sure the experiments are done right, that there is sufficient information to reproduce the experiment. We ask them when we send out a review, and we ask the reviewer, are there enough details to reproduce the experiment or not? And so they will look into this. And so it's not that the reviewers will completely neglect. So at least a few of them really pay attention to it. So a few of your readers who need to repeat the studies will read this portion very carefully and try to understand how to replicate the data. So, but only a few of them, because not everybody is trying to replicate your data. They just take it granted that you did it right. And they probably don't need to repeat it for whatever reason or adapt it for their work. So but there are some people who need this, and they need to repeat your stuff or adapt it for their own work and do whatever. So they will read it and they will get back to you and say, I can't repeat this. What's going on here? Give me more detail. This piece is a very important link in science that distinguishes from other literary pursuits, like poetry or something else, right? So it's very, very important link in science, and you really have to pay a lot of attention to this stuff. Learning how to write accurate, detailed, second ordered, organized section is important. And so that's the reason why we should do this. And the time and effort spent in developing this section actually determines the reproducibility, the intensity, usefulness, and the strength of your science. So this is like a trunk of a tree, and this has to be robust and well developed for the tree to stand in wind and rain and whatnot. So this is, I think, is really most important piece in science, which should be given its due respect. So as I was saying before, experimental has this outline. Each section has its own outline. And so the outline contains chemicals and resources and the purity, authentication of that, slightly more elaborate, 99% pure, analytical grade, and things like that. Instruments you have used, models and manufacturers. And so all that comes under chemicals and sources under one category. And then your methods, method 1, method 2, method 3, that comes in. And then the data analysis, 1, 2, 3, 4, 5 comes in here. So this is how you want to arrange your experimental section. The section should have all the details needed to reproduce data. That's the basic point. And pay great attention to this so that others can repeat. So here are a couple of examples from the book. And you have read many articles already. So you have most likely looked at the experimental sections of those papers. So this should not come as surprise, right? So you already know this stuff. I'm just trying to provide a different examples, so just to remind ourselves. So here is exact cell strain is given here. So that's the cell strain used, materials and methods. Necessary background is stated here. So plasmid that had been isolated from blah, blah, that blah, 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 blah. So relevant, so what is this and where it came from? And technical details, concentration, time, temperature, they're all necessary to repeat the experiment. So how they're gathered or purified or allowed to grow, whatnot. That's all that is given out with references, citations in them, right? So because these are known, and so they need to be referred to how exactly they were performed. And so this comes with all these details. Here is a bad one, right? The thumbs down, it says. Thumbs down section without sufficient detail. In situ hybridization, we performed in situ hybridization for all samples as described by these guys. cDNA extending from et cetera, codon, and so on and so forth. So what is missing? The details for PCR amplification is missing. How did you amplify? The temperature and even the buffers, which is really important, used for this. Unclear which processor used. So primers Y and Z. We don't know what is Y, what is Z is. What did you use? What is the sequence? And you got to know enough to be able to reproduce data, but this doesn't have enough to reproduce this data. Okay, how they were achieved. Amplification, repeated primer extension reactions were achieved using blah, blah, blah as a product. So it sounds interesting, it sounds scientific, sounds profound, sounds detailed, but if you look at it carefully and if you want to repeat this experiment, you say, no, I don't understand. What primer do I use? What is the temperature? What is the buffer? What's the length of time? And so many variables not defined in here. So step missing, what happens to probes and hybridization buffer after hybridization? And so all kinds of questions are asked and because they're not answered. So analyze it like this. So take a paper and then rip it apart if there are problems with it. What can you find is wrong with it? Not because you want to find something wrong with others, but because we want to learn what mistakes they have done. So if they did some mistakes, then we don't want to make the same mistakes. We learn from others' mistakes. So I used to do this and go through and then write myself notes. Don't forget to do this. 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 Don't forget to do this, and so on. So because we are so familiar with our method, what we have used for months and years, that we forget to give the details to others, but others are not familiar with those. So they need to know those things, right? So when to start writing? Well, this is the first one I would say, more or less before you do anything else, write first experimental before you do anything. Popular misunderstanding is that to write experimental first without literature survey, that's another thing that is misunderstood, because you need to know only after you have done a survey, which experiments are new, which experiments are already repeats. So the new experiments you're going to write with a brief reference to the already known experiments. So this is, by now, the literature search should be pretty well done in order to write the experimental. Deciding what to include in your paper requires a lot more planning than simply understood by the literature survey alone. So you have to start writing and say, what is relevant, right? For your paper, there are some irrelevant thing that you don't want to put in. And you may have gone tangentially in doing experiments, but then when you start writing, maybe you don't need all that. And so you got to figure out what to include, what not. And so again, the same triangle you have, experimental holds the triangle together and bonding, and then audience analysis covers all of them. Hinge on experimental, all these parts hinge on experimental, they hang from the experimental section. So this is something very important to recognize. And the checklist, and I keep doing this, why, when, how, and checklist. And so if you want, you can follow this to the letter, and you will be very well prepared if you follow these things and for your drafts. Experimental, chemicals, purity, instruments, methods, data. So I already showed you this. And so list all chemicals, biochemical cell lines, and the components used. Often purities of chemicals are also reported. If you don't report, then it's very difficult to figure out whether you should use 99.99% or 99% or 98% or 90%. What purity you want for doing the experiment that to get the result you desire. Some need to be very high, excuse me, high purity, others don't have to be. All the equipment used, all the manufacturers, the model numbers, etc. Because somebody has to repeat, even if they use the same instrument, you should be getting the same results, right? If they don't use the same instruments, still they should be able to get the same results. So you have to give all the details. Safety tips these days, they're looking to be very important. So people are asking about the safety and give exact procedures used and process the data, etc. So when you're writing an experimental detail, give some pointers to them. Hey, when you add this to this, color changes. When you add that to this, the precipitate happens, the bubbling happens. So give something that the reader can, imagine while they're doing the experiment. Then say, when that happens, they know they're on the right track. So a lot of the time we don't do that. We say, hey, add this to this and start it and filter, move on. So that's very dry. So try to make it interesting, even if it is experimental, right? And provide some guidance in terms of milestones that you should look for in an experiment so that they know they are in the right path. And so that's not often done. And you will see that, I ask you to look through statistical methods. If you have large data, you need to do that are used in experimental sections should be cited. And any changes made in the previous reported methods. So you can say, well, I prepared the same way as they did, but I changed some conditions, right? So you can say we used that method already published, but we made these changes. So say that. So it saves you space, time, and it's now precise how your experiment is done compared to what was already published. It could be just the amounts. They may have used 1 gram, using 10 grams. That's good enough, but you simply say that and modify it by using this or different time or whatever temperature, whatever it is. So how do you prepare for this? So inventory of all your methods. So you've done a bunch of experiments, make a list of all the experiments you've done, arrange them, and then make an outline for the experimental. Say which ones to include, which ones not to include. And then the ones I want to include, then for those you write down all the chemicals and supplies used for those methods. You don't do it from your memory. A lot of the time people are doing from my memory and say, I will write the same paragraph chemicals and supplies for every paper. It doesn't work like that. They will be different for different papers, and you need to pay attention to that. And so the instrument model numbers, you have to go to the lab, and then sometimes you have not recorded the model number, the manufacturer names and their locations in the country, and the country name. All those things have to be mentioned. Otherwise, nobody would know which instrument you have used. So all these details are required. Methods, citations. If they're known methods, you have to cite them. Then your description of the method is going to be very short. But if it is not a known method you have used, you've developed your own method, you would provide all these details, give milestones to guide the experimenter to follow through. Safety tips are really important, even if it is reported or not reported. A lot of the time, some of the chemicals are pretty dangerous, and so you want to be on the safe side. Statistics, analysis, etc. So this is how the experimental flow chart moves through. So if you have this chart and you adapt this chart as is, you cannot go wrong. I can assure you that. You may have to add a bit more or remove a bit, but by and large, this is what you need. And this is on the right path, okay? Organize, that's the key. Seamless flow into results and discussion. And if you have given methods in a sequence, use the same sequence of results, the same sequence, discussion, same in abstract, same in the introduction as well. So that's the really key. Take inventory of chemicals, take inventory of instruments, take inventory of substances, may say. There's all the structural data you got, or inventory of morphological data and all spectra of the data. All this is all inventory, making lists. I did this, I did this, I did this. So in fact, what I would suggest then is actually put all the data sets, graphs, etc., on a Word document, and then go back and make sure you have the method to explain that. Sometimes you have so many experiments or data you're putting in, you may have forgotten to write how that was acquired. So all the experiments have to be in place for the results to be included in your paper. Okay, so here is another experimental section, and just to give you an example again, oops. Cellulase mixture from this, and so here is the catalog name or number, and this is the company Novozymes that supplied it. In fact, we asked that you give the location, city, and the country, and generally that's provided Otherwise, it will be difficult to locate this guy, this company. So beta glucosidase, novozymes, this 188 is some number that they give for this particular product. So that novozymes 188, glucose oxidase, et cetera, Avicel. You can see how carefully they have been giving catalog number and name, and then chemical numbers as well, names as well, sources, so on. And you can also give a reference to how you purified it, and so on and so forth. All right. So same number 44 appears again here. And so it's okay to multi-site same reference. And other important thing I want to point out is that a lot of time we make this mistake, 50 space degrees centigrade. And a lot of the time we don't give this space. That's incorrect because that's two separate words in our word vocabulary, 50 space degrees. I mean, maybe you do already, but I see that so many times. And the degrees symbol is generated in very funny ways. It is not superscripted O. There is a specific degree key that you can use. And for example, on a Macintosh in Word, Option K gives you that nice little circle at the top, Option K. And a PC World, you can look in the internet how to make it. And so then, and the other thing I want to point out a lot of the time, say as a mistake is, say the number and the unit is given. And number is one word and the unit is a different word. So there should be a space between the two of them. And per molar is one word, per centimeter is a different word. There should be a space between them. So like this, this is the scientific format, how it is done. You give space in between the units and the number, and then between the units themselves. And so degree centigrade is a unit, and so there should be space between the number and the unit. And so that's the rule that we follow. So I think that's it. And then see how the citation is after the punctuation, superscripted, and is a punctuation and then superscripted. So by just looking at this, you learn all this stuff. And so there are a lot of things you can learn, how they're abbreviating and what abbreviations are allowed or not allowed, what you have to define, etc. So how to write this outline, the experiment, find out your chemical suppliers and the instrument models, and then write them all down in that sequence. So it's just a repeat of the same thing as I saw before. So this is just a practice session. You can take any paper and then look through, so what chemicals I have used, what you see if you can find out, from results and discussion, and you can work backwards and see if you can generate the experimental from there. And of course, you don't have the methods, and so you have to follow the methods they're given to you. So it's difficult to reverse engineer in the experimental section. So, but make sure there are detailed methods for all the experiments that you have reporting in it. All right, so we are running out of time as usual. There is another piece I've showed you again to recognize how it is written. So the synthesis of magnetic nanoparticles, they define MNP somewhere in the text, and so they can use that. In the synthesis of MNPs with a core size of about 200 nanometers, 1.350 grams of iron chloride, 3.854 grams of ammonium acetate, and 0.4 grams of sodium citrate were dissolved in 70 ml of ethylene glycol. Stored vigorously for an hour, 170 degrees centigrade, see the spacing between, to form a homogeneous black solution transferred into a Teflon-lined stainless steel autoclave and incubated 200 degrees centigrade for 16 hours. The black product is washed. See, the idea of saying homogeneous black solution. So you need to be able to get this black solution. If you didn't, there is some problem there. There's a transfer into Teflon lined, otherwise it will eat through the glass. At 200 degrees, the black product was washed with ethanol. So the product should be black, not white or transparent, and separated from the solvent using a magnet, because there are magnetic particles. You can use a magnetic field to pull them out of the solvent. Washing and separation steps were repeated several times to get rid of the solvent and other excess reagents. The final product was dispersed in ethanol for further use. Synthesis of magnetic nanoparticles with a core size of 100 nanometers. This is for 200 nanometers. This many grams of dissolved in this many. So it is very similar, but it's different. So at the same time, you have 200 degrees centigrade. for 20 hours. This was done for 16 hours, but this was done 20 hours. So don't ask me why, because they're all different, slightly different methods are used and for nicely different concentration, nicely different particle sizes. It's all growth and seeding nucleation. So another example here, another example here. This is associated content. Many times people don't do this, but you do. This is a supplementary information I was talking about. There is a specific format. Every journal requires one specific format of reporting this. So this is just, we'll cover it today, we're done. So the acknowledgements is another important piece. You need to acknowledge who funded it. If anybody that helped write, do this. So this assignment, we're running out of time here. Is in the given experimental section of a published, unpublished paper, pull 8 sentences that confront about items in the checklist I have given you. So this way you can go back and say, did they do this? Did they do this? Did they do this? So the idea is to learn how the master is doing, their locations. Just recognizing the location is good enough. Where are these? I rewrite this section in a simple word. So today you could do the rewriting of the introduction and the experimental after the class. When you go home, pick a few examples and write. Is a guided exercise as a writing model for this particular lecture. So repeat this kind of guided practice multiple times till you're very comfortable in writing your own, right? And so don't start writing your own until you've done this exercise on several papers that you already read for your topic. That would be easier for you, right? Rather than me giving and say, hey, do this. So pick your own thing, and then because you're going to use those as references. So you better know how they made those things. So you're much more well-versed in writing your own. So here is another one. If you don't find any, you can use this. I would put up a PDF of this after the class, so you're gonna have access to this. I probably did this already anyway. So see how they are writing all the details in parentheses. So these formats are very specific, otherwise the journal will return it to you. So you got to put the parentheses exactly the way they're suggesting you do, right? So this is, we ran out of time again. So just do at home, but to do give some feedback on this, what you learned or what you did not learn, and what you expected to learn, any questions from this material, anything to suggest, that you want us to do in the class, etc. So it's as usual. And so there are, put a PDF and then put it up in the ASCII. The practice of introduction experimentals we're going to do, you don't have to upload those. Those are for you to improve or practice your writing assignment. So this is the only in-class assignment. Every class we have one of those. And so 4 of those you want to put together and attach it for this week, for this module, excuse me. All right, so we'll stop